K cap. K cap representing the direction of the magnetic field along positive z axis, or you can say outwards. Or for you can use this sign also for outwards, or you can say towards the reader. Towards the reader. So in this way, you have to solve the question. Because here you have combination of 4 wire. I have divided this whole wire into 4 combinations. 1, 2, 3 and 4. So just you can take the screenshots. Hamza, taken?
1 minute.
Okay, okay.
Okay, done.
Okay, I am scrolling down. Now take the screenshot. I'm just zooming it out. Just please wait. This is the whole question. You can take the screenshot. Okay, Hamza. So means for solving these types of question, you should know first the formula. Okay, first the formula you will know when you will revise your note. Okay, I have already told you about all these things. From my side, all these things I have told you. So these are the two questions, and now we will discuss about the planes. Planes means planes means if I am having a wire like this, if I have a wire like this, like this. This is the wire I have. Okay, this is the wire I have, and suppose the current in this wire is flowing in this direction. Current in the wire in this wire is flowing means clockwise. Okay, the current is in this direction, like this, and this circular wire is placed in xy plane. Is placed in xy plane. XY plane means plane of your screen. Plane of your screen or plane of your paper, I have told you, is the XY plane. XY plane. So when you will find the direction of magnetic field, just apply the right hand, modified right hand thumb rule. Just curl your finger along the sense of current. Then you will get the direction towards the screen. Means inward you will get. Okay. At the center, the magnetic field will be inward, like this. Now, if you have a wire like this, and this wire have the current in this direction, suppose, and this is this circular wire again in the form of again in xy plane. So can you tell me the direction of the magnetic field, Hamza, by applying the right hand modified right hand thumb rule? Modified right hand thumb rule.
What's it?
I am saying that this this wire is in xy plane, na?
Yes.
This is a circular wire, and the direction of current is in this direction, represented by the arrow.
Yes.
And when you will apply the modified right hand thumb rule, so can you tell me what is the magnetic field at the direction of the magnetic field at the center?
It will be Z, right?
Of course, it will be in Z direction. Means positive Z or negative Z?
Negative.
No, just curl your finger along the sense of current. Curl your finger along the sense of current. The thumb will be towards you. Towards you means positive Z axis. Okay. So sorry, this thing will be cross. Okay, this thing will be cross and this thing will be cross. Understood? This represents the positive Z axis. And now this is all about the XY plane. Now I am taking YZ plane. XY plane I was discussing. Now I will discuss YZ plane. Suppose your wire is in YZ plane. Now what is YZ plane? YZ plane is like this. Uh, YZ plane is like this. Suppose this is your XY plane. Suppose this is your XY plane, and there is a ring. There is a ring which is like this. There is a wire which is like this on this. Suppose this this phone right now is on YZ plane. This phone right now is on YZ plane. Okay. Z axis means the axis which is perpendicular to XY plane. Okay, the axis which is perpendicular to XY plane. So this will be like something like this. This will be something like this. You can imagine. So, and the current in this is going like this and like this. If the current is like this, so this wire is in YZ plane. So of course you already know if this wire in is YZ plane, then the direction of magnetic field will be along x-axis. But positive or negative, that you have to decide. This will be given by the modified right hand thumb rule. Just tell me the direction. What is the direction?
Positive.
No, not positive. Just do it like this.
Sir,
Going in this.
I don't understand like how.
You have understood this?
No, sir, I'm a little bit confused.
Okay. Okay. This is a circular wire. This is a circular wire.
Yes.
And in this circular wire, the direction of current means, are you getting the direction of the current?
Yes.
Like
Yes.
this.
Yes.
So what do you have to do now? You have to apply modified right hand thumb rule. Modified right hand thumb rule I have discussed here. This is the modified right hand thumb rule. Curl your fingers along the sense of current. Then thumb will give the direction of magnetic field. Thumb will give the direction of magnetic field. Okay. So now see. See this now. Just try to try to curl your finger along the sense of current. Try.
My thumb is pointing towards the arrow.
Screen. Towards the screen, na? Listen one thing. Just try to curl your finger along the sense of current and see where your thumb is going. Away
Sir, like
from you.
around the wire, right? The thumb should be...
Around the wire. You have to curl the fingers like around the wire, like you are
Yes.
holding like
Yes.
this. So where your thumb is going? Away from you or towards you?
Away.
Away, na? Very good. Away means this is going into the screen, means the direction representing the into the screen, or
Yes.
if away from you means negative z axis. Away from you means negative z axis or into the screen, or into the screen, or in or inward. You can say inward also. So inward is represented by this cross. Inward direction is represented by this cross. Just I am writing it inwards. That is why I was telling you again and again, please revise, because direction is will confuse you always. Now see this example. See this example. You have the circular wire. Now just again do the same thing. Curl your finger along the sense of current and see where your thumb is going. This is so simple, Hamza. Curl your finger like this along the sense of current.
Yes.
So what is the direction of your thumb? You are getting
Outwards.
outwards. Very good. This time you are correct. Means for the straight wire, you have right hand thumb rule. For the curved wire, curved means circular wire, semicircular wire, or arc. You will use modified right hand thumb rule. Means now it is clear.
Yes.
Means we are just we were just calculating the direction of magnetic field. Good. So now this ring is in YZ plane. This ring is in YZ plane. Okay. YZ plane
Be
means
positive.
this. What? This is x-axis, this is y-axis, and this is z-axis. Okay, and this xy plane is on your screen, and z-axis is perpendicular to that. So just I am just removing it. I think you will confuse. So this is in the YZ plane, and just curl your finger now in the direction of the current. Curl your finger in the direction of current. So see your what your thumb indicating. Your thumb will indicate the direction of magnetic field will be in this direction. Okay, along x-axis, along negative x-axis. Okay, okay.
Yes, sir.
And when you are taking a coil in YZ plane like this again, and this time your current direction is like this. Now just curl your finger along the sense of current and tell me the direction. And always remember that this direction is positive x-axis and this direction is positive y-axis. Just do. And you have to find the direction of magnetic field at this point. So just curl your finger. You will get the direction of magnetic field along positive x-axis. Okay. These are the just example I am just giving you. We will use these in this example in the question. And suppose if your coil is in XZ plane. So XZ plane, what will be the XZ plane? Just see this type of, okay, means just let me explain you how XZ plane will be. So if your plane is like this, suppose this is your plane now, this is your plane. So if the coil is like this, means like this is the coil. So this represents the mm, xy plane, oh sorry, yz plane. Your coil will be in yz plane, okay. And when uh, your coil will be on this plane, means xy plane, okay. So now we were discussing the xz plane, oh, not xy plane, just this is xz plane. So xz plane will be like this. First see how, like this, okay. Means your ring is the plane, okay, like this. So if suppose the direction of current is like this, current is like this, and the direction of the magnetic field you want to find. So the direction of magnetic field will be definitely along the y-axis, okay, definitely along the y-axis, okay, Hamza. Just apply here right hand thumb rule, modified right hand thumb rule. You will get your thumb in the downward direction. Here you will get the magnetic field in this direction along negative y-axis. And suppose you have a coil like this, and the current in this is this. When you will apply the right hand, modified right hand thumb rule, so you will get the direction of magnetic field in this direction, positive y-axis. Okay. So Hamza, this is about the plane. Means you have to imagine this in 3D. Okay, but one thing, if you know the modified right hand thumb rule, then easily 100% you will get the direction. Okay. In the starting, there will be a confusion, I know, but with practice, so just note it down. You can take the screenshots. Hamza, taken?
Yes, sir.
Hamza, one thing, XY plane is clear now. What is XY plane?
Yes, yes.
XY plane means, just you can consider XY plane as the plane of your screen or plane of your copy. And YZ plane means if I am putting this mobile phone like this. So this is YZ plane. This is YZ plane. If I am putting my mobile phone like this, okay. So this will become the XZ plane. Means this phone is in this time will be in XZ plane. means this coil have some z coordinate also. Okay. Okay, so just we will not waste our time anymore. Just take the screenshot of this also. When we will solve question, you will know what is happening. Taken, Hamza?
Yes, sir.
So now next thing is the questions that we will discuss. These four questions. See this question. Here is one circular wire. Here is another circular wire. Okay, and you have to find the magnetic field at the center. And radius of this smaller circular wire is A, and radius of this bigger circular wire is B. Okay, and suppose this wire is 1 and this smaller wire is 2. You have to calculate the magnetic field at point O. So first what you will do, you will calculate just V1, and for the circular wire at the center, what is the formula of magnetic field? Mu naught I divided by 2R. This is the formula. When you will check your notes, you will get the magnetic field due to the circular wire at this point O is equal to mu naught I divided by 2R. And for calculating the magnetic field for this wire 1, so you will write V1, you will apply mu naught I divided by 2 into what is the radius of this bigger wire? Bigger circular wire is B, so you will write here 2V. For V2, similarly you will write mu naught I divided by 2A. Okay. And now can you find the direction of magnetic field due to this wire 1, Hamza? Can you find the direction? Inwards or
Wire
outward?
one.
Due to the wire 1.
Inwards.
Very good. Inwards. For inwards means negative z axis. Inwards negative z axis means what you will do when you will convert this into the vector form, you will just multiply it negative of k cap. Okay. And for the wire 2, tell me the direction. For the wire 2.
Wire 2 outwards, right?
Yeah. Because the thumb will points towards outwards means positive z axis. So when you will convert this into vector, you will multiply it with k cap. So finally, the total magnetic field at point O is the vector summation of V1 plus V2. Okay. And now put the values of V1 and V2. This is the value of V1. Okay. And plus, this is the value of V2. Very simple question these are. When you got the direction, when you got the magnitude, then nothing else means everything will be easy then. So this is the total magnetic field. Now the thing is here. Now you have to take common from both the terms. Take common. When you will take common, this mu naught I by 2 is common from both the terms. Mu naught I divided by 2 is common. Okay, and this is minus 1 by B of k cap. This is plus 1 by A of k cap. And finally, you will get your answer mu naught I divided by 2, mu naught I divided by 2, and this is minus 1 by V plus 1 by A, and K cap you will take common. So this is your final answer. This is your final answer. Hamza, is it fine?
Yes, sir.
Formula you should know, and you should know the direction. Okay, just take the screenshot, then we will discuss next question. Just a minute. Hamza, done?
Yes, sir. Done.
Okay, now taking this question. See this question. In this question, uh, this is the wire 1. Okay, this is the wire 1 and this is the wire 2. Means these are circular wires or circular coil, you can say. And this wire 1 is xy, is in xy plane, and this wire 2 is in yz plane. So we have to just calculate the magnetic field at point O, and radius of all the wires means you can say radius of this is A and radius of this wire 2 is B. Okay, radius of this wire is, so what is the magnetic field at the center due to wire 1? Due to the circular wire, the formula is this, mu naught I divided by 2R. So mu naught I divided by, or the current here is I, not I, take this current as I1 in first wire and take the current I2 in the second wire, like this. I2 current is in the second wire. Okay, so what you will write, mu naught into I2, just a minute. First you should know the formula for this. For the circular wire at the center, the magnetic field is this. Okay, this is the magnetic field. So for the wire 1, when you will apply this formula for the circular wire 1, you will write this as V1. So mu naught I1 divided by 2 into R. What is the radius of first wire is A? Radius of first wire is A is 2A. Okay. And for V2, you will write mu naught I2 divided by 2B. Okay, because radius of second wire is V. Now we have to calculate the direction. So for this wire, just apply modified right hand thumb rule and tell me the direction. Just try it. and the another is in the YZ plane like this. Hamza, are you getting?
Sir, 1 minute.
Okay,
Something
just
happened. I can hear
okay,
your voice, but I cannot see the screen.
okay. I think your internet issue. Check your internet first. Just I am sharing it again. Okay, just leave that.
No, sir, I cannot open. I cannot see Zoom itself.
Oh, oh, I
I can hear
think
your voice.
you
One
can
minute, sir.
hear
Let
your
me.
actually your laptop issue there is. So you can just restart your laptop and rejoin the meeting.
1 minute, sir. I'll just
Okay,
switch off this.
okay, no problem.
Now it's
I
back. Now it's back, sir.
it's back now. So now Hamza, you can you tell me due to this current I1, what will be the direction of magnetic field due to this wire one? For this wire one, what is the direction of the magnetic field along which axis?
Wire 1.
Yeah, see this wire only.
Sir,
Wire
it's
one.
along the Z axis.
Negative z axis or positive z axis?
Mm, positive.
No, just if no, just apply the modified right hand thumb rule. Curl your finger along the sense of current. Okay, so this is the sense of current. Just curl your finger along the sense of current means your thumb will going away from you. Away from you means negative z axis. Okay, away from you means negative z axis, or you can say this as inwards, right?
Yes, sir.
If you will not, if you are not getting, then uh, please tell me. Okay, this is so simple. Now can you tell me this another second wire, are you getting this another second wire? The direction of the current in this wire is given, and current in this wire is I2, and this wire is in YZ plane. This wire is in YZ plane. So the magnetic field at direction of the magnetic field, what will be the direction of the magnetic field at the center? Just curl your finger along the sense of current and tell me the direction of your thumb. The direction of your thumb will tell the direction of magnetic field for this V2.
Second wire.
Yeah, this second wire, this wire.
It will be along X axis and
Yeah,
positive.
yeah, this time correct. Positive Z axis. Very good. So what is positive Z axis is this now?
Yes.
This is positive Z axis means this is right or left?
Right, right.
Right. So towards right. I think now you are getting the things. So if you will convert this into the in the vector form V1, you will write first the magnitude. This is the magnitude now, this value. So this is mu naught I1 divided by 2a, and this direction represents the inverse direction, and inverse means negative z axis. Inverse means negative z axis. For negative z axis, what is the unit vector? For negative z axis, what is the unit vector? Just check your notes if you don't know. There are three types of unit vectors: I vector, J vector, or K vector.
Yes.
So which type of vector will you will use here if your direction is inward? Okay, just try. Okay, no problem. So actually, just I am telling. I am telling.
Sir, X, it will be I.
I is for x-axis.
Yeah.
I am talking about this. Talking about this. This is actually this represents the negative z axis. Just check in your
J
notes.
cap.
Minus j cap.
Minus J
Minus,
cap.
not minus j cap, minus k cap. Okay, so
Okay,
this
yes,
is,
yes, K cap.
yeah,
Sorry.
this is minus, this is v1. So now for v2, when you will convert this v2 into vector, so first you will write this thing, mu naught I2 divided by 2v, divided by 2v, and towards right means toward positive x-axis, positive x-axis, and which vector, which unit vector is along positive x-axis? I cap, j cap, or k cap, or minus I cap, minus j cap, or minus
Towards
k cap?
which one, sir?
Towards positive x-axis.
Positive x-axis, I cap.
Yeah, very good, very good. I cap. Now the game is over. You will just add total magnetic field you want to find na, at point O. So this will be the summation of magnetic field due to the wire 1, means V1 plus V2. Just put the value of V1 and V2, mu naught I divided by 2A, and this is minus K cap, plus this is mu naught I2 divided by 2V, this is I cap. Okay, Hamza? So this is your required magnetic field at point O. Further calculation I think you can do. Further, for the further calculation, you have to take this, take common mu naught I. This is actually I1. You can take mu naught by 2 common only. Okay. So this is your final expression of the magnetic field. Okay. We will solve next question, then things will become more clear to you. So Hamza, I think it is looking like this is complicated for you. Is it or not? Mean this topic is you are feeling that this topic is complicated, I think. Hamza? And there is one more student in this class, but I think she is absent today. So just you have to find the direction as well as magnitude. There are a lot of things here. Means first you should know what is the formula for the circular coil, and after that you will apply this formula, and after that you have to find the direction, and after that you should know the unit vector, and after that you will do the calculation. I can understand there are a lot of things here, but with practice, believe me, you can do this. I can only show you the path, but you have to follow the path. Now, Hamza, I am having this question. Actually, I have this question. Now, this is something different. This question. Uh, See here. Just look at this figure. Look at this figure now. Closely, when you will look at this figure. Okay. Closely, when you will look at this figure, means what is happening. You can suppose this point as A point, this point as B point, this point as C point, and this point as D point. Okay, so you have actually 4 wires. Means this is the single, this is a wire like this, and this, and this, and this, and this, and this. The current is flowing in this wire like this, and from B to C, from C to D, from D to A. The current is flowing like this. And dimensions are given, and you have to find the magnetic field at the center O. And this is these both are arcs, circular arcs. Okay. So what you should do, you should divide this wire into 4 parts for reducing the complexity of the question. For the simplification, you can divide this wire into 4 parts. So I am dividing AB as a one wire, BC as a second wire, CD as a third wire, and AD as a fourth wire. Hamza, till here everything is clear?
Yes, sir.
Okay. Now what is AB? AB is a arc. AB wire is a arc, na? Just I will. AB wire is an arc, means circular arc. Circular arc. And what is AD and BC? Straight wire or circular arc? AD and BC. This wire, this is a wire AD. This is a wire BC. These are circular arcs or means straight wire. Hamza, just see this BC and this AD. These are the straight wire, na? These are straight. See, so straight wires. Means you have the circular arc, this AB wire, and this DC wire is circular arc, DC wire. So for this, you should know two formulas. First, for the magnetic field of the circular arc, and you should know how to calculate the magnetic field when straight wire is given. Okay. So what you will do, when you will calculate the magnetic field at point O, net magnetic field is the summation of magnetic field due to wire 1, vector summation, wire 2 plus wire 3 plus wire 4. Now take wire 1. This is your wire 1 and this is your circular arc. This is your wire 1. This is your circular arc. And what you will do, Hamza? You have a formula for the circular arc. For circular arc, suppose this is the circular arc and this circular arc is making an angle alpha, and at point O you want to find the magnetic field, and suppose the current I is flowing here. What was the formula? Formula is mu naught divided by 4 pi I into alpha divided by the radius, if R is the radius of the wire. Is it or not?
Yes, sir.
This is the formula. We have already done this, but for revision I am telling you. Now see only the wire 1. Just a minute. See only this wire number 1. This is a circular arc, and this circular arc making an angle of 60 degree. Making an angle of 60 degree, na? Okay, just calculate V1. For V1, you will apply this formula, mu naught upon 4 pi. Mu naught upon 4 pi. V1 means magnetic field due to this wire V1. So this formula you will apply, and current I is flowing. Current I is flowing, so you will write this as I Why? What is the radius? What is the radius of this first wire? Can you tell me the radius? Radius is this distance OA. Okay, OA. Radius is B. OA is B. And what is alpha? What is alpha you will use? Alpha you will use 60 degree angle is given. This angle is given in degree, so you will convert this into radian. How you will convert this into radian? You will multiply this with pi by 180. So I think you have not revised your notes. That is why you are not getting 60 divided. When you will do this, you will get this pi by 3. So here you will write pi by 3 for V1. Just first calculate the magnitude. After that, we will discuss about the direction. This is V1. Now for V2 means magnetic field at the center due to this second wire, and in the starting of the lecture, I have told you this case. When the point lies on the axis of the wire, the magnetic field due to the wire is 0. This is the wire, and you are just calculating the magnetic field at a point which is on the axis of this wire. Okay, so due to this wire second, the magnetic field will be 0. So V2 is equal to 0. Now just calculate V3. See, V3 means magnetic field due to wire number 3. So this is the wire number 3, and again this is a arc. So again you will apply this formula, mu naught divided by 4 pi. Mu naught divided by 4 pi. Current I, Y, and what is the radius this time you will use here for this wire, Hamza? Hamza?
It will be minus A.
No. Radius means this OD you have to calculate. OD. Can you calculate this OD? Just listen. 1 minute. OD is the radius of this wire number 3.
Sir, actually I was saying OA minus A. That A you wrote no length.
Yeah. Right. Means your answer is correct. OA minus BC.
Or you can say OB minus A.
Yeah. OB minus, yeah, very good, Hamza, very good. OB minus A, or you can say simply OB minus this AD or A. So means simply you will say B minus A. You can B minus A, na? Okay, just see here. I think this is confusing. I know that. Just clear your confusion. This distance, na? This distance is B, and this distance is A, and you want to find this distance. So just B minus A, when you will do, you will get this radius. Okay, OC. Fine, na, Hamza? Now it's okay, na? Okay, fine. I think now you have got it. You want to find OD, so you will write B minus A. Oh, okay. Actually, the problem is na. This is not the case. I have made it complicated. No problem. But at least we have this. So, what is the radius I should take here? B minus A. And what is the value of alpha this time here? Pi by 3 again, because this wire is also making an angle of 60 degree here. So alpha you will take. You will take this pi by 3. V3, and what is V4? Now you will tell me with the value of V4. Hamza. You cannot learn physics by only watching the video lecture, you have to interact also if you want that your physics should be better and you should score 100 out of 100. So Hamza, tell me what is the value of magnetic field due to this wire for AD. Just take your time. This is the straight wire again. And we are calculating the magnetic field at the center O. Just think, check your notes. I want to ask that due to this wire AD, what is the magnetic field at this point O, as this point O lies on the axis of this AD? Think that. Just apply your mind. We have just done. Just think. I am giving you 1 minute. Think it.
Sir, I do not remember.
Okay. Arey, just I have told you na. See. Don't worry, don't worry. I have told you if you have a straight wire like this, and if you want to calculate the magnetic field at a point P, suppose, which is on the axis of the wire, and suppose any current is flowing in the wire, then the magnetic field will always equal to 0. So see here. This is the wire AD na. Due to this wire 4, you want to calculate the magnetic field at this point. So what you will do, you will check this point is lying on the axis of this wire. Do you know what is the axis? Means when you will join this wire, then this wire will meet this point O. This is the axis of the wire na, this O. So due to this wire AD, the magnetic field will be 0.
Yes.
I don't think you are waiting. Okay, no problem. So the magnetic field due to the wire 4 is 0 because the point O lies on the axis of wire. I am writing here. Because point O lies on axis of wire 4. Same is the case here. Because point O lies on its axis. Now it's fine. And what is this? This is the V1 and V2 are the magnetic field due to the circular arcs. Okay. So now forgot this V2 and V4 because V2 is also 0 and V4 is also 0. Now what we will do, we will just convert this V1 into the vector. Just can you tell me the direction of magnetic field at the center due to this wire 1? Just curl your finger along the sense of current and you will get the direction of the magnetic field due to the wire 1 along the negative z axis. Means you will just k cap, multiply it with k cap, and this pi and pi will be cancel out. So this v1 vector will become mu naught i divided by this will become 12v for v2 For V2, what you will do? When you will find the direction of V2, this direction will come towards you, means positive Z axis. So what is not V2, for V3? For V3 I am talking about. Because V2 is 0, na? So just multiply it with K cap, positive direction. So this pi and pi will cancel out. So V3 vector, you will get this as mu naught divided by this will become 12 minus A into I and K cap. So finally, when you will put all the values in the equation number 1, suppose this is the equation number 1, and you will put V1, V2, V3, V4, and V2 and V4 is 0. See here, V2 and V4 is 0, just you will only put V1 and V2. So finally, V is equal to, just put this value, V1 mu naught I by 12B, and this is minus K cap, plus this is mu naught I divided by this is K cap. Okay, now this is your final magnetic field at point O. This is your final magnetic field at point O. Now take the terms common from the both the terms. From here, what is common? Mu naught I is common, mu naught I is common, this 12 common. Okay. So mu naught I divided by 12 is common. So this will become 1 by B. And this will become minus 1 by B, because here K cap is also there. And this will become plus 1 upon V minus A. And this is K cap. When you will take common K cap also, mu naught I divided by 12. So this will become 1 divided by V minus A minus 1 by V, and this is K cap. So this is your final answer with so much of hard work. Finally, we got the answers. Okay, I'm just note it down. Take the screenshot.
Answer.
Then na? Question like this, na? This is B and this is A. B minus A. And take this now. Now, are you arranging your screenshots in a proper manner, or just
Yes, sir.
you are
Date, time, everything, even time.
very good, well done, well done.
Like
Because
in Zoom, I'll take screenshots, so it will
yeah,
come together. It will not jumble.
because I am telling you, when we are just on the moving charges and magnetism. After this, we will have natural magnetism. After that, we will have electromagnetic induction. We will have alternating current, and after that, we have electromagnetic wave. We have
Sir, can we do electromagnetic induction next?
sorry, Hamza, there is one more student now, so
Sir,
I have
because
to.
exam is coming, I have to do that.
So when will be your examination?
Sir, it's coming soon, in
Soon
October.
means you can tell me the date now.
In October, sir.
Okay. So okay, just let me finish this chapter. Okay, then we will start.
Because this
Okay.
chapter is not there in that. Two chapters are there. What's the name? AC,
Oh,
alternating
altern.
current,
Hmm.
and EMI, electromagnetic induction.
Okay, अच्छा.
So I do not know the numericals and how to solve them.
But Hamza, I want to tell you one thing, na. Means these are not your final exam. That these are the your just school exam, na.
Summative, yeah, but they're important, sir. Internal marks.
Internal marks. But actually, the thing is that uh, for a study for the study of the electromagnetic induction and all that, you should know about this magnetic field. Okay, if you will not know the magnetic field, so about the direction and all that, these same things will be used there. If this portion is weak, then for me it is not a big deal. Okay, okay, we will think it. Okay, Hamza, think about it.
Okay, sir.
Taken the screenshot.
Yes, yes.
So one more question I have. I have this question now.
Sir, can I leave now? My father is calling
Why?
to eat,
You have
sir.
to go. You have to go somewhere.
No, no, I have to eat. Everyone is